Hello everyone, so today I will be discussing Open Shortest Path First, or OSPF. So what is OSPF? OSPF is a link state routing protocol which is used to find the best path between the source and the destination router using its own shortest path first algorithm. A link state routing protocol are one of the two main classes of routing protocols used in packet switching networks for computer communications. It is also a protocol which uses the concept of triggered updates. For example, if there is a change observed in a learned routing table, then the updates are triggered only, not like the distance vector routing protocol where the routing table are exchanged at a period of time. OSPF was developed as a replacement for the Distance Vector Routing Protocol (RIP) or Routing Information Protocol. Figure 11.1 is the classification of routing protocols. OSPF's major advantages over RIP are its fast convergence and its scalability to much larger network implementations. RFC 2328 defines the OSPF metric as an arbitrary value called cost. So let's go back to the history of OSPF. The initial development was on 1987 by the Internet Engineering Task Force or IETF OSPF Working Group. And on 1989, the specification of OSPF version 1 was published in RFC 1131 with the two implementations written. One is to run on routers and the other runs on Unix workstations. And on 1991, OSPF version 2 was introduced in RFC 1247 by John Moy, and it offered significant improvements over OSPF version 1. And ISO, or the International Organizations for Standardizations, was working on a link state routing protocol of its own called ISIS, or Intermediate System to Intermediate System. But IETF chose OSPF as its IGP, or Interior Gateway Protocol. On 1998, OSPF version 2 specification was updated in RFC 2328 and its current RFC for OSPF. RFC 2328 OSPF version 2 is on the IETF website. On 1999, OSPF for IP version 6 was published in RFC 2740 and was written by John Moy, Rob Colton, and Dennis Ferguson. OSPF message encapsulation. The data portion of an OSPF message is encapsulated in packet. This data field can include one of 5 OSPF packet types. Each packet types will be discussed in the next topic. So in this figure shows an encapsulated OSPF message in the Ethernet frame. OSPF packet header is included in every OSPF packet, regardless of its type. In the IP packet header, the protocol field is set to 89 for OSPF, and the destination address is typically set to one of two multicast address, which is 224.0.0.5 or 224.0.0.6. If the OSPF packet is encapsulated in the Ethernet frame, the destination MAC address is also multicast address 01-00-5E-00-00-05 or 01-00-5E-00-00-06. OSPF packet types. The following list describes the 5 different types of OSPF. This is only an overview of the packet types. Some of these packet types will be discussed later in this chapter. Each packet type serves as a specific purpose in the OSPF routing processes. Hello. Hello packets are used to establish and maintain adjacency with the other OSPF routers. DBD or the database description checks for database synchronization between routers. LSR or link state request request specific link state records from router to router. LSU link state update sends specifically link state records. LSA ACK or link state acknowledgement acknowledges the other packet type. Hello protocol. In this figure, 11.3 shows the OSPF packet header and hello packet. So let's focus on the uses of hello packet. OSPF packet type 1 is the OSPF hello packet. Hello packets are used to do the following. First, discover OSPF neighbors and establish neighbor adjacencies. 2. Advertise parameters on which two routers must agree to become neighbors. Number 3. Elect the designated router and backup designated router on multi-access networks such as Ethernet and a frame relay. Important field shown in the figure includes the following, which is the type or the OSPF packet type, which is hello or DD or link state request, link state update, and link state acknowledgement. Number 2. Router ID. It is the ID of the originating router. Next, area ID. Area from which the packet originated. Network mask, which is the subnet mask associated with the sending interface. Next is hello interval, the number of seconds between the sending router's hellos. Router priority used in DR and BDR election, which will be discussed later on. Designated router or DR, router ID of the designated router. BDR is the router ID of the backup designated router. List of neighbors. List the OSPF router ID of the neighboring routers. Neighboring establishment. Before an OSPF router can flood its link state to the other routers, it must determine whether there are any other OSPF neighbors on any of its links. In figure 11.4, the OSPF routers are sending hello packets on all OSPF-enabled interfaces to determine whether there are any neighbors on those links. Full adjacency happens after both routers have exchanged any necessary LSUs and have identical link state database. OSPF hello and dead intervals. Before two routers can form an OSPF neighbor adjacency, they must agree on three values, which is hello interval, dead interval, and the network type. The OSPF hello interval indicates how often an OSPF router transmits its hello packet. By default, OSPF hello packets are sent every 10 seconds on multi-access and point-to-point segments and every 30 seconds on non-broadcasting multi-access segments. OSPF hello packets are multicast to an address reserved at 224.0.0.5. Dead interval. Death interval is the period expressed in seconds that the router will wait to receive a hello packet before declaring the neighbor down. If the dead interval expires before the routers receive a hello packet, OSPF removes the neighbor from its link state database. The router floods the link state information about the down neighbor out all OSPF-enabled interface. Note: also, before two routers can establish OSPF adjacency, both interfaces of the two routers must be part of the network and the same subnet mask. Selecting a designated router and backup designated router. To reduce the amount of OSPF traffic on multi-access networks, OSPF elects a designated router and a backup designated router. So what is designated router? DR is responsible for updating all other OSPF routers called DR others when a change occurs in a multi-access network. Backup designated router, or BDR. This router takes over DR's responsibility if DR fails. OSPF Link State Update (LSU). Link State Update are the packets used for OSPF routing updates. An LSU packet can contain 11 different types of LSAs as shown in the figure below. The difference between the terms like link state update and link state advertisement can sometimes be confusing. At times, these terms are used interchangeably. An LSU contains one or more LSAs, and either term can be used to refer to the link state information propagated by OSPF routers. OSPF algorithm. OSPF routers build and maintain link state database containing LSA received from other routers. Information found in database is utilized upon execution of Dijkstra's PF SPF algorithm. SPF algorithm is used to create SPF3. SPF3 used to populate routing table. Administrative distance is the trustworthiness or preference of the route source. So in this table is the default administrative distances. The default administrative distance for OSPF is 110. Authentication. The purpose is to encrypt and authenticate routing information. This is an interface-specific configuration. Then the routers will only accept routing information from other routers that have been configured with the same password or authentication information. Basic OSPF configuration. The lab topology. The addressing scheme is discontinuous. So since OSPF is a classless routing protocol, the subnet mask is configured in this table shown on the screen. Clock rate. Clock rate is a command in this configuration is used only to provide a signal for the serial link. The router OSPF command. So to enable OSPF on a router, use the following command. Router OSPF process ID, in which process ID is a locally significant number between 1 and 65,535. This means it does not have to match other OSPF routers. So this is the example of the router OSPF command. The network command. The network command is used with OSPF has the same function as when used with other IGP routing protocols. Any interface on a router that match the network address in the network address in the network command will be enabled to send and receive. This network or subnet will be included in OSPF routing updates. The network command is used in routing configuration mode. So this is the command that we're going to use. Network, then the network address, wildcard mask, area, and the area ID. The OSPF network command uses the combination of network address and a wildcard mask similar to EIGRP. OSPF requires the wildcard mask. The network address along with the wildcard mask is used to specify the interface of range of interfaces that will be enabled for OSPF using this network command. So when we say wildcard mask can be configured as the inverse of the subnet mask. For example, in router 1, Bus Ethernet 00 interface is on the 172.16.1.16/28 network. The subnet mask is 255.255.255.240. So, 255.255.255 minus 255.255.255.240 is equals to 0.0.0.15. So this is the wildcard mask. Note: some Cisco iOS software versions allow to simply enter the subnet mask instead of wildcard. Next is area. Area ID. Area ID refers to the OSPF area, wherein OSPF area is a group of routers that share link state information. All OSPF routers in the same area must have the same link state information in their link state databases. OSPF network can also be configured as multiple areas. Advantages in configuring large OSPF networks. It is smaller link state databases and the ability to isolate unstable network problems within the area. The network commands must be configured in the same area ID on all routers. To make it easier if the network is later configured as multiple OSPF areas, where area 0 becomes the backbone area. So this is the example of the router OSPF command, router space OSPF space 1, and the network commands network 172.16.1.16 space 0.0.0.15 area with an area ID of 0. So that would be all. Thank you.